Cool. All right, so we're recording. All right, so we enter all the data set into L1. So now what we want to do, we want to just say what we've been doing. Yeah. So we go up here, we go to stats, we go to distribution. Oh, sorry, we go to test, and we do a t-test. So if you look right here, it says stats and data. So for this problem, since we have data, you want to choose data. So we put mu is 15.7. And then we put our data list, which is A. All right. So let's see all the information that we want to do. Yeah. So if you look at it, it gave me 3 options for my p-value. So the p-value that I want, the one for that says less than, because my alternate hypothesis said it should be less than 15.7. So that's one of the ones we're going to use. We also want to use this t-value over here. All right, so if you look at it for t-value, we get negative 2.74439. Also, if you look for p-value, we get it to be 0.00644. And also, like, one thing that you should want to look at, you do want to look at the sample mean. Okay, if you look at the sample mean, it's 15.09. And if you look at 14.09, it is smaller than 15.7. So if you look at the t-value kind of telling us that the difference of 15.7 and the sample mean of these 20 sunflower, it did get smaller. But with the t-value telling us that this difference of pretty much like 1.7 centimeter is a significant difference. But also the p-value is also telling us that. So let's go ahead and move over to my notes. So you get t, which is negative 2.74439, and we get p-value, which is 0.00644. Everybody good with those two? All right, so let's go to alpha. So if you look at my problem, alpha isn't given. So anytime alpha isn't given, what you want to do, you just want to say alpha is equal to 0.05. That's our kind of like rule of thumb. If alpha ever is not given, you just automatically assume it's 0.05. Because anything below 0.05, we consider it to be abnormal. So if you look at my alpha, which is 0.05, if you look at my p-value, which is 0.00644, which one is smaller, p-value or alpha?
P-value.
Yeah, p-value. So since p-value is smaller than alpha, we say reject HO. So since we reject HO, we'll say there is enough evidence to support the claim that the mean height of so for this one, we'll say there is enough evidence to support the claim that the mean height of the sunflower did get lower after the treatment was applied. And that's it for the last problem. Any question for that last prompt? All right, so let's go ahead and do this next one. So this next one is called quality control. So for quality control, so Susan is in charge of quality control in a small fruit juice bottling plant. Each bottle produced is supposed to contain exactly 12 fluid ounces, FLOS, of juice. Susan decided to test this by randomly selecting 25 filled bottles and carefully measuring the amount of juice inside each. She will recalibrate the machinery if the average amount of juice per bottle differ from 12 fluid ounces at the 1% significant level. The sample 25 bottle has the average of 11.92 fluid ounces per bottle and a standard deviation of 0.26 fluid ounces. Should Susan recalibrate the machinery, state the null and the alternate hypothesis? Alrighty then. So let's go ahead and just label everything. So let me kind of minimize this. So if you look at it, they gave us 12 fluid ounces. So we have to see what does that represent. They gave us 25. We have to figure out what that is. All right. They also gave us 11.92. And they also gave us 0.26. And they also gave us 1%, which is 0.01. So we have to figure out what that is. All right, so let's go ahead and do this. So what does the 25 represent?
Sample size.
Sample size, perfect. So that's my N. All right, let's see, let's do 11.92. What is 11.92?
X bar.
Yeah, X bar, perfect. Okay, if you look at it, they give us a sample, and then right next to that sample, they tell us the average is 11.92. That's how we know this is a sample mean. All right, let's do 0.26. So what will 0.26 be?
Sample standard deviation.
Perfect, sample standard deviation, so S. So 0.01 will be what?
Significance level.
Yeah, so alpha. Lastly, what does the 12 represent?
Mu.
Mu, perfect. Cool. And the reason that's mu because that's what they're claiming, like the fluid ounces should be for the juices, because they're claiming that it should be 12 fluid ounces in each one of them. So that's why you say mu is equal to 12, because that's their claim that if the machine is working properly, it should always be kind of giving somewhere around 12 fluid ounces. All right, so now let's go ahead and do this problem. So the first thing we're going to do is the null hypothesis and the alternate hypothesis. So the null hypothesis will be mu is equal to 12. And we could say mu and 12. So for this one, what are they trying to prove? Are they trying to prove that the machine is overpouring, underpouring, or is both of those scenarios bad? Or do we want to say not equal to?
Not equal to.
Yeah, good. So for this one, it should be not equal to. Could kind of think about it. If this machine is overpouring, well, that's bad because they're losing profit, because essentially if it's overpouring, that's money that the machine is wasting. But if it's underpouring, that's also bad, because if you kind of think about it, like if you go out to buy this juice and instead of having 12 fluid ounces, you only have 11 fluid ounces, you're gonna feel like you got ripped off. So you're probably not gonna be buying this juice anymore. So that's why you want to put not equal to, because essentially if they pour too much, that's bad because they're losing money. But if it underpour, that's bad also because they're gonna be losing customer. Also, if you look at the problem, they say differs, where differ is the same thing as saying different. All right. So we're all done with null and the alternate hypothesis. Any question for the null or the alternate hypothesis? All right, so let's go ahead and now we're going to transition over to class cow. So go here, class cow, go to share. Cool. All right, so here you go, class cow. Let me erase this for that way it can look nice. So we go to stats, we go to tests, and we do a t-test. So for the t-test, what we'll put mu, which is 12. We'll put x bar is equal to 11.92. S is 0.26. And then n is 25. So if you look at my test statistic, it's a t is equal to negative 1.5385. So let me show you what am I looking at. So here's my test statistic. If you look at it, they gave me 3 options for p-value, but since we say it was not equal to, it's this one. So we say p-value is equal to 0.137, so on and so forth. All right. Everybody good how I got p-value and how I got the test statistic?
Yes, sir.
All right, so I'm gonna go ahead and get transferred back to my notes. So if you look at it, I put t is equal to negative 1.5385. If you look at p-value, I put 0.137. So if you look at my alpha in this case was 0.01. So I say alpha is 0.01. So now we have to figure out which of these two is bigger. Is p-value bigger or is alpha bigger? So which one is bigger?
P-value.
Yeah, p-value, perfect. So p-value bigger than alpha. So since p-value bigger than alpha, we fail to reject. Cool. So we fail to reject. So we're saying this is still true. So we're saying that the machine are actually still working properly and we don't need to recalibrate the machinery because since we said the null hypothesis, since we failed to reject the null hypothesis, we're essentially saying that the machine is still pouring out at 12 fluid ounces. So let's put that. So say there is not enough evidence to say that the mean juice So say there is not enough evidence to say that the mean juice this machine give is different than 12 fluid ounces. And that's it. Any question in regards to the last problem? All right. So what I want you to do, I want you to practice on this next problem. So I want you to go through the step where you notate all of these numbers. You say like, what's my mean? What's my standard deviation? What's my, and take note of that. Once you take note of that, I want you to do the null and alternate hypothesis, do the test statistic, get the p-value, and lastly, make a conclusion. So in anywhere that part you get stuck, you can either private message me, or if you want, you put it in the chat and I'll let you know if you're on the right track. So I do want you to practice, because just remember, like, me doing it is not the same as you doing it. Like, me doing it is not actually you practicing, it's me practicing. So in order for you to practice, you actually have to go ahead and start doing this problem. So try doing this problem. If you get stuck, either private message me or put it in the chat. And that way I can let you know if you're on the right track or if you need a little bit more help. So try doing this problem. All right, guys, so let's try doing this problem. So I'm going to go ahead and label everything. So hopefully the labeling shouldn't be an issue. All right. So those are all of your information. So we have mu is equal to 20,500. We have x bar is equal to 19,850. We have s, which is 1,084. And lastly, we have n, which is 14, and alpha, which is 0.05. So we have all of that information. So for the null hypothesis, that one should be pretty simple. Is HO of mu of 2,500. So the alternate hypothesis, this is where some of you got kind of like hanged up on. So if you read the question says a used car dealer said that the mean price of a 2008 Honda CR-V is at least 20,500. You suspect this claim is incorrect and find that the random sample. So we suspect that this is incorrect. So we don't believe it actually at least. If I don't believe it actually at least, what do I believe it is?
Less than.
Less than. So that's why for this we want to put less than. Because essentially what we want to do, we want to disprove this person. So the null hypothesis is actually saying the dealer is right. My alternate hypothesis is saying that the dealer is wrong. So the null hypothesis where we say mu is equal to 20,500, that's me saying the dealer was correct. But where we say mu is less than 20,500, that's me saying that no, the dealer is actually incorrect. All right, any question in regard to that? All right, so let's go ahead and move over and let's go to class calc. So in class calc, what we want to go ahead and do, we want to go to stats, we want to go to tests, and once you go to tests, you go to t-test. So you enter mu is 20,500. You go to x bar is 19,850. S in this case is 1,084, and n will be 14. So if you look at my t value, we get it to be negative 2.2436137.5. Also, if you go ahead and look at your p-value, so for the p-value you want less than, p-value is equal to 0.02145513. All right. Any question on p-value or t-value?
No.
All right, so let's go ahead and go back to my notes so that way we can finish this problem off. So t is negative 2.24361375. P-value is 0.02. If you look at my alpha in this case was, I think, 0.05. Yeah, 0.05. So if you look at alpha, if you look at p-value, alpha is definitely bigger than p-value. So since alpha is bigger than p-value, we reject HO. So we could put there is enough evidence to say that the mean price of this Honda model is less than advertised, which was 20,500. All right, and that's it for the last prong. So for this one, we'll say there's enough evidence to say that the mean price of this Honda model is less than 20,500. Right. Any question in regards to the last prong? All right, so what I want you to do, I want you to practice some more and practice on this next problem. So same thing, once you get the answer, or if you want to double check on anything, just either private message me or you could just put it in the group for everyone to see. All right, so let's go over this problem. All right, so for this one, what you should have gotten is mu is equal to 14, because that's what they're claiming. They're claiming it should be less than 14. So you say mu is equal to 14. They're also saying they sampled 10 people. They found the sample mean to be 13, and they found the sample standard deviation to be 3.5. Lastly, they found alpha to be 10%. All right. So let's go ahead and do the null and alternate hypothesis. So for the null hypothesis, we're going to say mu is equal to 14. So mu is equal to 14 is not supporting the DMV claim, because remember, the DMV claim is saying that their wait time is less than 14 minutes. So for the alternate hypothesis, we put mu is less than 14. So HO will be mu is equal to 14. H1, or the alternate hypothesis, will be mu is less than 14. Any question in regard to that so far?
No, sir.
All right, so then for the test statistics, let's go to class cal. Let's calc it up. We go to class cal here. It's already here, so let's just enter it. So my mean is 14. Well, mean of the population 14. Mean of the sample is 13. Sample standard deviation is 3.5. And lastly, we get our sample size to be 10. So if you look at what do we get, oh, here, let's do this. So for this one, we get T, that's weird. We get our T value, which is over here, and we get the P value, which is over here. So we get T is equal to negative 0.90350079. And we get our P value is equal to 0.1948994. All right, so that's my alpha, and that's my, that's my P value, and that's my T value. Everybody good on how to get the alpha and the T value? All right, so let's clear the screen. So lastly, let's go back to my notes. All right, so if you look right here, I got T is equal to negative 0.9034079. You can round them up. Like usually for the P value, you just round it up to like 4 decimal places. For the T value, 2 decimal places. All right, so P value is equal to 0.1948994. My alpha is equal to 0.10. So you have to compare alpha to P value. If you kind of see this, P value is significantly bigger. So it's kind of telling you this could happen just by random chance. So since P value is bigger than alpha, this say we fail to reject HO. So since we fail to reject HO, we say there is not enough evidence to support the claim that the mean wait time for the DMV went down with this new app. All right, so that will be it. So say there's not enough evidence to support the claim that the mean wait time for the DMV went down with this new app. So yes, it did slightly go down from 14 minutes all the way to 13 minutes, but it's saying it's not a significant difference for us to pretty much support that claim that it's now always going to be below 13. And also, if you look at the sample size is pretty weak because if you look at the sample size, they only had a sample of 10, so that's not that impressive. All right, but that's it for this last problem. Any question in regard to this last problem? Alrighty, so let me stop sharing. Go. All right, so let me show you your homework for today. If you can't remember if you're from yesterday, well, it's the same place. So for your homework, what you want to go ahead and do is go over here to hypothesis testing. You click over here, home. And then if you look right here, today we did test of significance sigma is unknown. So you want to be able to do this homework. So you should now be able to do this homework from this page. Sweet. Also, today is your very last quiz. So you're going to take quiz number 19, and that's the last of your quizzes. So that means next week there is no more quizzes. All of the quizzes are all gone or pretty much done. So you do want to start practicing over the weekend on exam number 3. What is gonna be pretty much the rundown for next week is gonna be review on Monday, review on Tuesday, test on Wednesday, review on Thursday, and then test on Friday. All right, so you do want to go to exam number 3. So if you look at exam number 3, it's not available. Well, actually, it's gonna be test number 3. But the pre-exam is already available for you. So you could go over there and start practicing for that way. Test number 3, you could do awesome on test number 3. Also, what I'm gonna do, I'm gonna actually open up the final exam. So we'll say make available. We'll go down here. We'll put the final exam and we'll make that unavailable for you. So if you want, you could already start practicing for the final exam. So you could go to the pre-exam, well, pre-final exam, and you do that. Yeah, you do have the activity today. Activity should be activity number 20. Thank you, Arvin. Okay. For the quiz today, if you remember, the quizzes are always covering what we just learned the last day. So pretty much what we did today is not on today's quiz, is what we did yesterday. So pretty much whatever we did yesterday, which is hypothesis testing with sigma was known, that's what the quiz is gonna cover on today. So it should be what we went over yesterday. And for today's activity, now you should be able to do activity number 20. But for activity number 20, skip problem number 2 is missing a sample mean, so don't worry about that one. All right, so that's pretty much it for this. All right, so the pre-exam for test number 3 is already up. The pre-exam for the final is already up. So yes, no for next week. Next week is essentially going to be all review. So Monday, Tuesday, we're going to review for test number 3. Thursday, we're going to review for the final. And then on Friday, you're going to have your final exam. And on Wednesday, you're going to have your third exam. So let's do this. All right, guys. So any question before essentially you sign off? And also just remember, you still have SI workshop all the next week. So you still have it Tuesday and you still have it on Thursday. So you do want to finish strong for that way you could get those 5 percentage points. Okay, just remember those 5 percentage points can be the difference between you either getting a C or you getting a D, or you getting a B, or getting a C, or getting an A, or getting a B. So do attend because essentially that's just for attending. So pretty much you get the 5%. So if you attend it every single day, you get those 5 percentage points. If you haven't shown up at all, well, you're not gonna get those 5% point. So you're gonna be in a disadvantage. So do just attend because it's there to just help you. Like it shouldn't hurt you. This is only supposed to help you. All right. Any other questions before I close down this meeting?
You're still having office hours next week, right?
Yeah, I'm still having office hours, so office hour will still be the same.
Thank you.
Yeah. All right. So I'm gonna close out the meeting. I'll upload today's notes. I'll upload today's lecture in case you showed up late or you had to leave early. So, all right, guys. Have a good weekend. I'll see you Monday.